about laws of motion. What is laws of motion? What do we mean by laws of motion? Uh, what are laws? First of all, what are laws? Laws are nothing but we can describe laws as any set of guidelines guidelines or rules. So every motion or movement of a body follows certain kinds of laws or for certain kinds of guidelines during its occurrence. For example, if we consider the motion of a body, motion of a body, uh, of a body, like a box. A box is here, and a boy is pushing this box. Is pushing this box with his hand, and this box is in with his hand. So he is moving the box. So he is moving the box with the help of following certain kind of guidelines. So we are going to learn certain kinds of we are going to learn that kind of guidelines. Before reading that guidelines, we need to know about few terms, such as few facts, such as a boy can push a boy two bodies. Certain terms such as force. What is force? Force is nothing but an external cause. External cause means I am writing because I exert a force on the pen, and I am placing my hand on the table, means I am exerting a force on the table. So force is an external cause, means it is done by an external agency which changes or tends to change, means it is able to change, or it has the property to cause the change. It has the property to cause the change, or it tends to change the position of a body, position, shape, size of a body. For example, here is a box. A boy is pushing the box, so he is exerting a force in the box. A boy is reading. A boy is reading means he is a boy is reading means he is exerting a force on the book. Similarly, it tends to exert a force on the body, means here is a wall and a boy is trying to push the wall, means a boy is trying to exert a force on the wall, means he tends to move the wall. He tends to move the wall. Then comes the law of inertia. Another term is inertia. What is inertia? Inertia is nothing but the property of a body to remain in rest or in motion. Means it is a property, it is the nature, it is the tendency of a body to remain in rest or in motion. For example, if I am leaving this copy as like this, so the copy will not move unless and until I am trying to move the copy. Means if I am moving the copy like this, then the copy moves up front above, and if I copy bring like this, if I bring the copy like this, it will come below, it will move downwards. So unless and until an external force is applied on the body will remain in the state as it is. We have seen in this in many cases. For example, in a merry-go-round, or a fly wheel. Here there is a support, and here there would be an operator. unless and until if the flywheel is an ideal machine, unless and until the operator um, does something with the main control board, the unless and until the operator does something with the control board, the flywheel will not stop. It will continue. It will be in motion. It will continue to be in motion. Similarly, if the operator uh, on the flywheel, it will move on, and if he offs the it will if he offs the switch, the flywheel will stop. Unless and until an external force is applied on the flywheel or on the control board, the flywheel will not stop moving round and round. So this property of a body is called as inertia. Inertia. Inertia are of three types. Inertia are of three types. Inertia of rest. Of rest. Inertia of rest. Rest means to be motionless. Inertia of rest means the property of a body to be in rest unless and until an external force is not applied. A practical example can be created here, where when I am leaving this copy, then no motion is created in this copy. But when I push the copy or pull the copy, then a motion is created in the copy. Then comes the inertia of motion. Whenever a bus is moving, then the bus will continue to move. When a bus, for example, a bus is moving here, the bus will continue to move unless and until an external force from here or from here is applied. It will continue to move with same velocity and same speed in the same direction. And comes the inertia of direction. Inertia of direction is a practical example when people meet with accidents when they take a sharp turn. Direction. This states that a body will remain move in the same direction unless and until an external force is applied. For example, when we take a sharp turn, when a bike takes a sharp turn, it has more tendency to skid because it will a certain force is acting on the bike. So and the bike was initially moving in a particular direction. After clearing the basics, we can move to the laws of motion. First law of motion. First law of motion. First law of motion. This law is also known as law of inertia, which we had learned in the previous section. This law is also known as law of inertia. We can skip this one because it is similar to the previous one. It states that a body will remain in rest or a body will remain in rest or in motion unless or until an external force is acted upon it. Means, for example, if you bring a book from the library, it's a book and it is kept on a table, and if unless and until you pick up this book, the book will remain on the table. It will never move on its own. Then if a book will not come to the same table unless and until someone keeps the book on the table, over the table. Let us consider another example. A car is moving on a road. The car will move on the road unless and until an external force is not applied a force, if an external force is applied, then the car will stop, then and only the car will stop, or the car will continue to move, or else the car will continue to move. If the car is in rest, if the car is in motion and an external force, if the car is moving like this and a force is applied in the opposite direction, then only the car will come to rest, or a force will is applied in this direction, in the same direction as the motion of the car, then only it will accelerate, or else it will continue to be to move in the same direction and in the same velocity. The car is in rest means force it is in rest unless an external force F is applied on the car from this direction or from this direction, the car will remain at rest. The second law of motion. Now comes the second law of motion. What is second law of motion? Second law of motion means second guidelines of motion means this law states that every body on the surface of earth contains some momentum, has some momentum. So the rate of change of momentum means momentum is defined as the amount of motion contained in a body. Means here if it is a box, it is moving like this in the x direction, x axis, in the x axis. So the in the x axis with the velocity v, so the momentum p equals to m into v. And a simple example can be taken as a bus containing passengers is moving on a road with a velocity v. So the bus, we can define the motion of a bus as the momentum of a bus as mass into velocity, means mass into velocity times of motion is contained in the bus. Suppose more specifically, when if the mass of the bus is 20 ton and if its velocity is 20 meter per second, then the total momentum of the bus is 20 ton into 20 meter per second. 20 meter per second. Momentum is now we got the definition of the momentum. So second law of motion states that the rate of change of momentum, the rate means the amount of the rate, which means that the amount of change per unit time. If the bus has here momentum equals to m into v, where mass of the bus is equals to 20 ton, velocity is equals to 20 meter per second, momentum p is equals to 20 ton into 20 meter per second. So the rate, we were discussing the rate is defined as the amount of change per unit time, any change per unit time, so or the amount of change per unit time. So according to the second law, the rate of change of momentum, change of momentum on a body is directly proportional to the force, directly proportional to the force applied on the body. If we consider the definition, the rate means the amount of change on the momentum. The rate of change of the momentum. The rate means the amount of change on the momentum, means amount of change on the motion contained in the body, on the body, is directly proportional to the force applied on the body, which is obviously true. Means if here it is a bus and which contains the passengers, if the driver of the bus accelerates the bus, then and only the bus will move with more speed, means it will contain more momentum, it will contain more motion. Anyone who stands outside the bus will tell that the motion of the bus is more, the momentum of the bus is more, unless and until the driver of the bus accelerates the bus will not move. So and if the driver accelerates in forward direction, then and only the bus will move in forward direction. And if the driver of the bus will accelerate or de-accelerate the bus in accelerate the bus in reverse direction, the bus will move in the reverse direction. Its momentum will be in the forward direction or in the reverse direction, depending on the driver of the whether he moves the bus on the forward direction or on the reverse direction. Then comes the third law of motion. Third law means third guideline of which motion follows. It is obvious. This law states that this law states that to the every action this law states that to the every action there is equal and opposite reaction. This can be done with a simple experiment which I am going to conduct here. With the help of this pen, I am going to exert a force on the on my palm. And see that what is going to happen when I exert a force on my palm. The palm is getting pressed with the force of the pen. Similarly, on the other hand, the palm is exerting a force on the pen, which is revealed on my other hand. So when I am giving an action to my palm, the palm is giving a reaction to my hand. So this states the third law of motion, which can be imagined as like this. Suppose this was my palm. This is my palm. And if it is a pen, and if I exert a force on my palm like this, then the palm would exert a force on my on the pen, which will be going to reveal on my other hand. You can conduct this experiment in your home. Here I had missed a thing. I had forgot to write that F is equals to dP by dt, means dF is equals to instantaneous force is equals to instant rate of change of instantaneous momentum. dF vector dP vector. In the next class we are going to that's all for today. In the next class we are going to learn about impulse and the law of conservation of momentum.